Okay.
Hi, Mitra. We're live. Good evening and welcome back to day 3 of Refining and Petrochemicals World IE 2021. We now have our panel discussion on biofuels, renewables, and alternate energies. We have as our moderator and anchor presenter, Dr. Anjan Ray, Director IIP Dehradun, who will be presenting an overall perspective in India on alternative fuels. We have on our panel this evening, Mr. Satyendra Joshi, Joint General Manager, Advanced Biofuels and Renewable Gas, Praj Industries. We have Mr. Shantanu Gupta, Chief General Manager, INC Alternate Energy and Sustainable Development, Indian Oil. We have Dr. Dilawar Singh, MD and CEO, Sun Brilliance Group and President, IBC Australia. And we have with us Ms. Shilpi Mittal, Manager, Project Engineering, McDermott International Inc., India, and the SABR Biorefinery, Australia. Over to our anchor presenter and moderator, Dr. Anjan Ray, to take this session forward on biofuels, renewable and alternate energies.
Thank you, Ms. Mavis. Good afternoon to all our esteemed panel members, and everyone who has joined us on live stream. For this session, in which we are going to look at product flexibility in refining and petrochemicals with biofuels, we have a very distinguished panel, and I'm going to request each panel member, when their turn comes, to speak for no more than 8 to 10 minutes with no more than 5 slides. We would request you to kind of stay focused on the theme of the presentation. And let us start with the context that India or any other growing economy that is dependent on fuel imports today is essentially importing carbon atoms, whether we do that as petroleum, coal, or natural gas. To reduce dependence on imported energy sources, we have 2 broad choices. The first option is that we reduce carbon demand and we go to non-carbon sources like solar, wind, geothermal, green hydrogen. We just heard about that. Or we improve energy efficiency of carbon consuming energy systems like boilers, IC engines, diesel gensets, and so on. The second option is to improve domestic carbon supply by converting domestic carbonaceous waste to fuels, preferably, as we will see, to advanced and drop-in biofuels. And if that were not enough as the set of challenges, we have to do this sustainably to meet our emissions goals for both greenhouse gas emissions and atmospheric emissions. We also have to do this with minimum water consumption, as most of our refiners in India are finding out. And we have to maximize profit, which is why as refiners move towards petrochemicals, the slate of options is getting more and more complex and potentially more and more capital intensive. So I have a short presentation. I will share my screen if that is it. I hope you're able to see the slides. Are my slides visible, please? Yes, thank you. Yeah. And as I said, we are a carbon atom importing country. We pretend we're importing fuels, but actually we're importing carbon atoms, about 350 million tons before the pandemic per year. And we can choose to either reduce that requirement through demand side responses or find 350 million tons of domestic carbon on the supply side. As it turns out, if I look at all the possible technologies that are known for all the fuels that we use, we actually have enough carbon atoms in India to replace our entire import basket. We throw away more than 500 million tons of carbon atoms every year, not including massive coal reserves. So in theory, we could be completely import independent. In practice, we know that's very far away because we are locked into certain supply chains, into certain infrastructure, into certain asset structures. But as we look at the technology evolution and the supply chain evolution and the replacement markets, can we actually change the way the refining and petrochemicals market works, and therefore how the assets operate in the context of biofuels, bioenergy, and biocarbon. So if you look at, I'll just take a simple example, one that is close to my heart, a biojet fuel. India is surplus in petroleum kerosene. We have a huge surplus of jet fuel in India. So why would we do biojet fuel at all? Well, the answer is it's one of the relatively low-hanging fruits for deploying biological and renewable carbon, because we can use hydrogen for a domestic installation. We can use biodiesel, we can use electric vehicles, but when it comes to a plane, it is a lot more difficult to replace that fuel with any of the alternate energy pathways. So it turns out that if we focus on biofuels for a moment and we look at hydroprocessed ester fatty acids, a very basic technology today at demonstration scale in India, the supply chain is primarily food value chain byproducts, but even these are substantial. If I add up what's available in India and what is known, this is not inventing anything, we still have 8 million tons of carbon atoms, more than enough to fly every plane in India within our domestic flights. So estimated available today, if I simply look at what's collectible, that's a very small fraction. Of the 8 million tons or 8 billion liters, we have less than 0.05% being collected today. So it's not a technology issue, it's a supply chain issue. And when we request our colleagues to address their comments in the session going forward, please keep an eye on supply chains. Let us not only talk technology. Let's talk about the 4 basic questions of: 1, will the bioequivalent give you comparable performance? Will it give it to you at adequate scale? Will the cost be affordable? And will it be truly sustainable? So performance, scale, cost, and sustainability against these 4 indices. Here is an example. Today in Dehradun itself, we are able to collect more than 2,500 liters per week, and we are able to turn that into biodiesel at competitive cost at that very small scale of just a few barrels per day. We are also able to produce biojet fuel on a continuing basis. We have an MOU signed with an engineering partner, and there is a demonstration plant PFR, which is under preparation for a refinery in South India. In conclusion, for my very brief summary, we can see that biofuels will significantly enhance India's energy security, reduce petroleum and possibly natural gas import dependence. And the constraint is not technology, it's scalability based on supply chains. Our policies are conducive, as we can see, but they need to move even more quickly towards technology neutrality and enforceable mandates if we want scale. And if we are able to achieve this sustainability at affordable cost and deploy rapidly across India, maybe many more places will look like our campus where I'm currently sitting. Thank you. I'm now going to hand it over back to the our anchor person so that she can invite the next speaker. I think our anchor has dropped off, leaving it to me. So our first speaker is from Praj Industries, Satyendra Jain.
Yes, sir. Good afternoon.
You may please take over, and please keep an eye on the time, not more than 10 minutes. Thank you.
Thank you. Thank you, sir. Yeah, so is my slide visible?
Yes, sir. We can see it. We can hear you clearly.
Thank you. Thank you. Good afternoon, everyone, and thank you, sir, for the inspiration and the words you said. So you covered the different ways of how we can basically cater all the renewable sources and the potential available in our country. So I will just cover the technological part on that. So we have basically tried to cover all the spectrum, that is the basket offering from technological point of view. and we have coined it as biomobility solutions, which basically denotes the carbon neutral renewable fuel, which is produced from different biological sources, starting from first generation ethanol, second generation ethanol, sustainable aviation fuels, different marine biofuels. So these are the different areas which we can cater to basically reduce the greenhouse gas emissions and to decarbonize the environment. So there is a rise in transportation fuel demand, and we can definitely offer these different fuels, so different technologies for producing these different fuels in order to reduce the carbon footprint. So few of the technologies which are there in the first generation ethanol are for fermentation related, distillation related. So these technologies are being offered as a part of the first generation ethanol. As a part of the second generation ethanol, we cover the agri residues as well as the forest residues. So Infinity technology is basically covered, is offered for the agri residues, and for the forest residues, the salinity technology is being offered. Then we have this compressed biogas, which can be produced from different biomass, as well as waste from sugar factory. So it can be converted to a fuel which can be directly used as a replaced, and renewable fuel is currently being produced in India. So already covered the biodiesel. So we offer the eco diesel technology platform, which is offered, which produces the biodiesel. The sustainable aviation fuels are also in the basket, which is being produced from different feedstocks such as sugar, starch, biomass. And the last one is the marine biofuels, which is again produced from a waste, which is from cellulosic biomass. So these different renewable energy sources can be utilized to produce these different fuels as a part of the renewable fuel, which can definitely help the economy as well as the social community, and then obviously reduce the carbon footprint and reduce the overall emissions. So in the first generation ethanol part, different offerings are there in basically to reduce the water, energy, as well as carbon footprint. So different technologies can be integrated, such as the biosyrup or the shift technology, that is the high brix fermentation technology, and the incineration technology, along with the distillation. So these can be integrated together to overall reduce energy, and in turn the carbon footprint, to overall reduce the overall emissions and reduce the GHG emissions for the first generation ethanol. Similarly, for the compressed biogas, along with the compressed biogas technology, different technologies such as the heated thin film dryer, along with the air-cooled heat exchanger, can be offered again to reduce the water, energy, and overall carbon footprint to improve the value of the entire chain. When we come to these different technologies, we have some numbers where we can see what numbers can be, how much GHG reductions can be taken over by different technologies. So, for example, starting with the sustainable aviation fuel from the corn, at present is having around 10 to 15% GHG reduction, followed by the corn ethanol between 20 to 50% GHG reductions, followed by the sustainable aviation fuel, if produced using cellulosic biofuels, can achieve a reduction up to 65 to 70%. The cellulosic ethanol can offer around 80 to 100% reduction in the GHG, and the CBG or the RNG can offer carbon neutral, that is 100% reduction, provided we use different feedstocks. So these are the potential which can be offered by these different fuels, which can be further further used for reducing the overall to mitigate the climate change. Using this expertise which is developed for fuels, the same can be experience and expertise can be applied to the renewable chemicals and materials, so that we just not only target the fuels but also target the chemicals and the materials, so that the overall impact on the environment, economy, and the climate can be reduced, and we can have a more sustainable environment. So if you see, if we achieve this 20% blending target using the cellulosic ethanol, it has a potential to reduce 26.7 million tons of GHG emissions, which is also equivalent to 5.5 million of passenger cars from the passenger cars. So it definitely has a very big potential if we apply the technology and have the things at the right place. So this is what I have today.
Very nice. Thank you, sir. Maybe we'll hold questions till the end. Not seeing any questions on the board yet. So let us go on to the next one, which will now be on biofuels and alternate energies by Mr. Shantanu Gupta, Chief General Manager in charge, Alternate Energy and Sustainable Development of Indian Oil. Mr. Gupta, over to you, please.
Yeah, good afternoon. Good afternoon, Dr. Roy. Good afternoon, sir. Nice seeing you after a long time. So, good afternoon to all the faculties here and viewers here. I will briefly tell you what the areas which are concentrating as an oil company and to propagate the bioenergy sector. So, I will just share my screen. Just share. Yeah, hope it is visible, sir.
Yes, absolutely clear. Thank you.
Thank you very much. So thank you, Dr. Roy, for giving a very interesting initial talks regarding that carbon molecules. Yes, that's a real challenge we are all facing in the generations, and also this century is going to be defining for the whole world. So we'll just see the way Indian Oil is thinking for making this, because being the leader in the oil business, starting from downstream and marketing. So this is what our sustainability vision, which comes in front, through which we are approaching the improvements of the product from the cleaner and fuels and the lubricants, promoting natural gas, supporting electrification of energy, and creating a circular economy. These four are the pillars of our planning process. So I will just quickly see that how we are targeting these things to happen. So we are going to have a clean product portfolio. These are the brands, various products, which is a snapshot of the various brands which is we are marketing. So here the very important part is IndiGreen. If you see that IndiGreen, there is a compressed biogas, 100% green auto fuel, which we have been branded, and also EV battery swap points. And with that, we are going for further, portfolio greening our portfolios. So we are in this solar power and heating technology. Already we have started. Wind power, we have a good number of windmills. Compressed biogas, which is the Satat initiatives. I will briefly explain that how we are propagating there. Ethanol, which is having the sugarcane based agreed residue, which is a 1G, 2G, 3G. All 3Gs we have touched upon. 2G ethanol plant is going to be ready by coming year, by March or April 2022. And 3G also from refinery of gas from Panipat is going to be commissioned in the next year also. Biodiesel from used cooking oil, which have been discussed by Dr. Roy, yourself, and the challenges, logistics challenges, you are very correct. It's on the dot. This is where the success of this used cooking oil will depend in the future. Plastic recycling, as we are in a polymer business, so we have been carefully drawing this recycling areas also. We have developed special grade crumb rubber modified bitumen, which to have the bitumen having with this blending with more of this sustainable products. Fuel efficient long-run lubricants, that's also one of the developments we have made. Differential fuel like XP100, XP95, all those areas we have been touching up with the differentiated fuel. And last but not the least, that HCNG. So hydrogen, blended CNG that we have already tried in the Delhi market. And it's a very successful trial run we had. Coming to creation of a circular economy. So with the organic waste to fuel and organic waste to energy, we have second generation ethanol plant which will be producing 100 kiloliter per day of ethanol from that paddy straw, and this lignocellulosic biomass which will be converted into this paddy bag. So through this process, we are going to address over 2 lakh ton of agri residues per annum once it is in the full capacity. And for the 1G ethanol biorefineries, which is the government had recently opened up that grain-based ethanol. So we are targeting few states which are the deficit states from that sugar-based ethanol. So we have kept our eyes open for going ahead with the setting up of the ethanol plant there, though we are taking some more time to watch about the industry developments. Coming to used cooking oil, to aim at the biodiesel for used cooking oil, we have developed one EOI through which we are inviting entrepreneurs. 24 such letter of intents have already been issued, which is the cumulative capacity of 22.26 crore liters per annum. We are targeting 100 crore per liters per annum. We know that 300 crore liters is the capacity which is available, having a full potential. But we are facing a challenges because it is having a competitive uses, and the part is going to back to the food chain, which is dangerous for the health, and that's also a big challenge because the premium is higher there. And other parts is for this other soap manufacturing and other manufacturing small scales. So main competition is that. So we are trying to get the whole collection mechanism at our various cities so that we can drive the used cooking oil tagged with the responsible food business operators and also the big hotels, at least to collect those things with a proper channel and bring it for the biodiesel plant for manufacturing. So these two plants have already started production. We have already started getting this used cooking oil based biodiesel and started marketing with the blending at 7% with the diesel. So we have kept 22 crore liters target for this year. So now coming year, we'll be adding further because we have tweaked the pricing so that we get a better value. That this diversion in the food chain can be reduced. I can't say that stop because there are, the various factors work. So, but we are trying hard to reduce that diversion. Emission reductions to this ethanol, which will be 20% blending, will be requiring 1,000 crore liters roughly to blend 20% across the country. So this will be equivalent to 9 million metric ton of CO2 reductions. And compressed biogas, we have an ambitious target of 15 million metric ton per annum by 2024-25. So this will contribute to about 14 million metric ton of CO2 equivalent reductions in the country. Coming back to compressed biogas, I will just give a brief on that because it's a very important and very urgent initiative. Lots of work is going on. Ministry of Petroleum is fully focused on that. So this is sustainable alternative towards affordable transportation, which was launched in October 18, with a vision of 5,000 CBG plant by 2024, which will be producing 15 million metric ton CBG and 50 million metric ton of biomanure. Here, this will be benefiting the organic farming. So we are trying with at the same time the emission control and the improvement of the soil health. So this is very important. Marketing of 50 million metric ton of biomanures is a challenge as per the comparison of today's conditions. But we are very hopeful with this enabling of different policies by Government of India, we'll be able to do that. So we have so far 2,557 letter of intent has been issued, which is we have crossed the halfway mark, and which is equivalent to 5.4 million metric ton capacity. So this is the balanced plant. These are the very small capacity plants are also coming. So, but here now there is a shift is happening. Big entrepreneurs are showing interest in this, and we will be going for a larger capacities of CBG plants in future. This is where today already 16 CBG plants have started producing CBG from various feedstocks, starting from municipal solid waste, the organic portions, then press mud, then cattle dungs and chicken litters. So these have already started. This is the map in India where these are being posted. You can see almost, except for eastern region, west and south and north partly covered. But there are another 50 plants in the various stages of completions, which we're expecting by mid of next year fully operational. Coming to renewable energy, we are mixing this solar and wind with our energy requirement, because we all know our refineries consumes quite high quantities of these things. The power is required. So we have greening that. We have seen the installed capacity is increasing from 2016-17 to 2020-21 from 188 megawatt. We have come to 233 megawatt. And also the RE generation has been, in the last year, it has come to 329 from 179, which was in 16-17. So within 4 years time, we have reached to this level. And there are more projects that are coming up. And also the emission reduction we have done to 260 TMT CO2 equivalent emission through this renewable energy infusion in our normal energy requirement. So other clean energy technology alternatives which we are considering, and we are also working very closely with this, that electric vehicle charging and battery swapping facilities. We are using our huge retail network for making these things available so that customers, they don't face any problem. Manufacturing of battery, that's also, we have developed a JV with an Israeli company, which is a startup for lithium, aluminum air battery. So hydrogen fuel cell, this work is very actively, we are working on this. Our R&D is having a full focus on that. Nuclear power also, we have a JV with NPCIL. So there also, we are working with them closely for nuclear power investment. And carbon capture, utilization and storage, this is one area where we all are very active on that. So this is going to define the future so that we are becoming emissions control, and also we become more environment friendly along with our change in the product portfolio. So I'll stop here. That's from my side. Thank you very much.
Thank you very much, Mr. Shantanu Gupta. As always, the canvas of activities and the level of deployment of IOCL from bench to field never ceases to amaze. My compliments. Let us hear now from Dr. Dilawar Singh, MD and CEO of Sun Brilliance Group, President, IBC Australia. We're looking forward to your talk. Over to you, sir.
Yeah, good afternoon to everyone. I'm based in Perth, so now I'm interacting with you. I'm going to cover first about the solar energy. That is my expertise in it. So I got my PhD from IIT Delhi long time back, and since then I'm continuing in this field. Just I want to cover something about this solar energy in Australia and India. Okay, so what is happening right now? So India and Australia both are going in a very big way for deploying the solar panels. But both the countries, they don't have the fully integrated manufacturing facility. So both of them are depending, Australia depending 100% on China, and India is depending almost 85% or 90% import of the solar panels from China. So if you look on this, the manufacturing side, so India has got almost 6 gigawatt of module manufacturing and very small capacity of solar cells manufacturing. Then come back to the this wafers manufacturing and polysilicon manufacturing. There is nothing in India and also in Australia. Just I want to share this slide. Just let's see. Suppose. Okay, is this visible?
Yes.
Visible to you? Yeah.
Yes.
Okay.
Yes.
Yeah. Okay. So this talks about the. Just I start from the beginning. Okay. Let's mode. Okay. This is the silica is the source for manufacturing the solar panels. So then from silica, it goes to the metallurgical grade silicon, then go to the making the polysilicon, very highly purified material. Then you go to make the ingots and slicing of the ingots into wafers. And then you go to solar cells manufacturing, then module manufacturing, and then the system installation. If you see the whole value chain, the India is only in the modules and a little bit of cells manufacturing. And if you see Australia, Australia also has got some metallurgical grade silicon manufacturing. There is only one plant here in Australia, but that is exporting all the metallurgical grade silicon to Japan. This company belongs to a Japanese company, so they take the 100% product of it. So there is no manufacturing of polysilicon or wafers or cells or modules in Australia. So India has a very big program, just as I mentioned earlier, but they don't have the this whole supply chain for it. If you see the targets, right now India has got almost 100 megawatt of installation of solar panels in India, but their targets are to go to about 350 gigawatt. So if you see the difference, and also calculate in terms of the import of solar panels from China, so India is going to just to invest almost 50 lakhs crore of rupees in coming next 10 or 15 years when these targets are achieved. So the huge amount is going to China for the import of solar panels. Just I give you the example of this the China. Before 2008, there was not a single solar panel manufacturing in China at all. And India had the solar cell manufacturing since 1977, when the Central Electronics Limited in Sahyadabad, when this CEL, Central Electronics Limited, they started manufacturing solar panels in Sahyadabad in India. But you see the China, in the last 13 years, they have become the number one supplier of solar panels, beating everyone in the world. So if India has to overcome this issue, they have to go for integrated manufacturing. But there are some recent announcement by Ambani, and that they want to go for manufacturing of polysilicon as well as wafers. Let's see how long it will take, but that's a good sign. If now the new things, what earlier in the discussions happened earlier about the hydrogen. So hydrogen is another fuel, but you require the power to produce the hydrogen. It is not readily available without without the electricity. And if you talk about the green hydrogen, you require the electricity to produce it. The use of hydrogen for producing the electricity from wind and solar farms. Then you have the this main sector, the transport sector, and the second main sector is the feedstock for industry. So like this aluminum, then steel industry, and even the refineries, and then you can manufacture methanol, ammonia, and other and transport sectors, this all the cars, bus, trucks, and even the civil aviation also. And after that, then you can have the storage, and then you just first convert to hydrogen, power convert to hydrogen, then again convert hydrogen to power. So that is another use of power. But right now, this lithium batteries are dominating in the market because the efficiency is almost 90%, and the efficiency of power to power of hydrogen is just around 50% now. But that is increasing, and we'll see next 10 to 15 years, it will be almost to 90% or so. So if we go to the next slide, so there are the generally three types of hydrogen. You see some people are also talking about the full rainbow. You can have the 7 types of hydrogens, like the pink and black, and also the red hydrogen also there from biomass. But generally the three hydrogens are very common. This is the gray hydrogen coming from the methane steaming, then the blue hydrogen, then you use this storage of carbon, You can capture the carbon, then come to the green hydrogen. So all are very much, these technology are mature now. And first two, gray hydrogen and blue hydrogen, they are already almost 90% production coming from there. And the hydrogen, the new, green hydrogen, the new, only recently some projects have started happening last couple of years or so. As far as Australia is concerned, there are 10 megawatts of electrolyzers are under installation in Australia right now. But right now coming, just producing one project only 250 kilowatt of this hydrogen right now. This is the current position in Australia. If you see the hydrogen, the competitiveness in the market, so this you see this blue line that shows the where this technology stay right now. But the above this blue line, this passenger vehicles, buses, trucks, remote area power supply systems. So they are the this application of hydrogen. They are commercially viable as of today. But if you go to the next below this blue line, so you see the industrial feedstock, grid farming services, agents and heat, synthetic fuels. They are not commercially viable yet. So but by 2030 or by 2050, there is hope. Yes, these also these application can also be coupled with the hydrogen. Just if you see the example of in the transportation sector, I give the example of the car. Just the car of IC car. In Australia, we on average we run a car for 400 kilometers a year, and using the 10.8 liters of petrol for 100 kilometers. At the price of actually $1.80 right now, the cost comes to about $2,600 per year. If you compare with the hydrogen car is an electric car. Instead of batteries, they are using the hydrogen gas in it and producing the electricity on the spot in fuel cells. So that using only 0.8 kilogram of hydrogen for 100 kilometers. And the cost at the rate of $5 per kilogram, this comes to only $540 per year. So this is far cheaper than the IC or the petrol or the diesel cars. As India imports the 85% of its fuel demand, so could hydrogen be a solution? So that's the question. And this Mr. Modi recently on the 15th of August, he launched this hydrogen mission, and expecting that India will become this hydrogen surplus country and will export hydrogen to other countries as well. So let's see how long it will take. This is the project I'm involved in. My company, Sun Williams, here in Australia. So we are setting up a 3.1 lakhs ton of green hydrogen project and 8 lakhs ton of green ammonia project. So this is the picture of the project. So this is this I conclude here, and I'm happy to take the questions. And also, if somebody wants to collaborate with us, we are willing to do so. So we have the expertise, and we can part with anyone in India. Okay, thank you very much.
Thank you, Dr. Dilawar Singh. Let's hand over to our last speaker for the session, Ms. Shilpi Mittal from McDermott International. Over to you,
Hi.
Dr. Singh, if you could please stop sharing.
Yeah, I just stopping here.
Okay. Hi, good evening, everybody. I had not prepared any presentation because I thought it was a panel discussion and we'll be discussing about sustainability and how to be flexible in a refining industry. Anyway, I'll have a very small presentation. I just pulled out some very small presentation of my company, what it does. But in short, what I would like to state is here, when we are saying biofuel, alternate energies, and being flexible. So for everybody, I think it is very important to integrate all these things, integrating biofuels, integrating greenhouse, reducing the greenhouse emissions, and other alternate energy. India, as such, it is a very big, it's a very big country, and we have very different geographical structures in all the zones. So we have to, as a united team, it is very important that we have to harness what alternate energy is suitable for which zone. For example, if you come to the west, the desert side, the solar energy, or we need to harness the wind energy. Similarly, if you go towards the north, towards the Ladakh side, you have those geothermal centers here. So we need to know how to, encash on those geothermal sites which is available there. Similarly, when you go towards the peninsular India, you have the coastal regions where you have to harness, you can harness wind energies, you can always harness solar energies by using floating solar panels. And similarly, when you go towards the east, there you can have solar energy, you cannot have solar energy, so you may have solar energy depending on which state you are looking at. And there, even in eastern states and some of the eastern areas, you have a lot of coal available there, and a lot of communities which are dependent on this coal. So when we are talking about changing it to renewable energies, we need to also look at from the social community angle. So it is not purely you're going, when you're looking at that. For example, let me jump back to the coal industries. If you're looking at that coal industry, so what we should be looking at as a team, as an energy expert, is how to reduce the greenhouse gas emission where we're using the coal plants. That is very, very important. So it is, when you're looking at sustainable energy, it is totally a mix of lot of alternate energies. So that is something which we should be, as an industrialist, maybe Indian Oil is coming up with a lot of different things. So for the refiners, there are almost 23 refineries, which includes, I think, 18 to 20, if I'm not wrong, Mr. Shantanu. I think there are 18, more than 18 PSU refineries. So the way to slowly get into the sustainable energy mode is first to understand what is the carbon footprint of each refinery, and slowly then you start working on those reducing the carbon foot. For example, you can say where the refineries are very old, you can change to green hydrogen. Similarly, where there are new plants, you can look at how much is the greenhouse gas emissions or equivalent is coming. So what are the technologies which are to be established on those areas? So that is something flexibility we should be talking at. I mean, if I look at India transformation, energy transformation, I see that India is targeting something like 175 gigawatts in um, 2022, and we are trying to, that is totally renewable energy I'm talking about, out of which 100 we are doing solar and the rest is other alternate energy. So as an industries, as a refiners, or other chemical manufacturers or fertilizers industries, we have to have an integrated approach for using sustainable alternate energies or the renewable energies and reducing the greenhouse gas emission. I just have 4-5 slides because I think we have another 13 minutes for this session to end. I just give you some idea about, because when refiners are going into that, consultants like McDermott, they are required to execute those projects. So I'll just present a small slide on my company's portfolios, what we have to offer in order to have that integrated, in order to help all the refiners to adopt that integrated approach. So I'll just share my screen. Please let me know if you see my screen. Are you able to see my screen?
Yes, ma'am.
Yes, we can.
Yes, ma'am.
Okay. So I'm not sure how much of you know about McDermott. So I thought that let me take this opportunity to just walk you through the some of the global capabilities of McDermott. So McDermott, we are 100 years, more than 100 years experienced company. We have almost 30,000 employees in around 54 countries. And we do everything. We do right from concept to commissioning. So we are into subsea, offshore, LNG refinery, petrochemicals, power, you name it, we are there in every this thing. So, and we also have, we are doing a lot of projects in India as well with IOCL. In fact, we are doing 3 projects right now in Baroni and Haldia. And with CBCL also, we are working on a project. And there is a one big petrochemical project which we are coming up in Tamil Nadu also, which is a feed which is undergoing. So in India itself, we have around 2,000 employees in India itself. We have a big portfolio on energy transition. Without taking much time, I'll just quickly go through it. So we are a company where we deliver low carbon delivery projects. We work so that the carbon emissions along with the objective of net zero emission is very much integrated into our systems. Then we are working on new energy projects where we harness wind, solar, and other alternate energies. We also do carbon capture, utilization, and storages. There is a new technologies which we have net power, where we're using natural gas to to generate power without without generating much of CO2. Whatever CO2 is generated, part of it is recirculated back into the system, and the part of it is sequestered underground. And we are working a lot on circular economy. We have executed a couple of projects where we are working on generating oil from the waste tires. So that is one big technology we are coming up with. These are the new energy projects which we have worked in recently and we are still working on. Offshore winds, HVDC platforms, HVAC platforms, then all kind of hydrogen, you name it, green, blue hydrogens, carbon capture utilizations. We have a number of projects in last 2 decades which we worked on CCUS, biorefineries, anaerobic digestions, where we the biogas, which Mr. Shantanu mentioned, that there are a lot of biogas plants there. Indian Oil is coming up. We can always shake hands on those issues. Energy storages, we help companies to have CAES, that is compressed air energy storages, in order to store it, in order to use it later in the thermal energy storages. That is where we also get into. Green and blue hydrogen, Hydrogen Council. We are member of Hydrogen Council, and we are also foundation member of Hydrogen Forward, which has been established in US. In green and blue hydrogens, we have actually delivered almost 200 plus projects world over. And here also we have sold a couple of hydrogen technologies in India as well. And we are a big storage solutions. Recently, we have got a project from NASA where we are building a liquid hydrogen spheres of around 5,500 cubic meters. It is one of its kind. It's a cryogenic hydrogen storage, one of its kind in the world. And this is just a schematic of various hydrogen generators, what we do, where we are. So I think a lot is talked about this gray and blue hydrogen. I don't want to get into the details of this. I think everybody is aware. So these are this is the forte of McDermott. Earlier, CBI India Private Limited, it is registered like that. So we build compressed gas bullets. We have cryospheres. And we also transport, in order to transport hydrogen in a more economic way, we have ammonia storages. We work on that. We generate green ammonia and also liquid organic hydrocarbon carriers for hydrogen. So this is one of our fortes. This is just a blow up of the largest hydrogen storage vessels or spheres which we are building for NASA. And this is one of its kind. I think we are a model. We also fabricate and we have big fabrication yards where we big modular projects we execute. On CO2 removal also, we have worked extensively in that area. We have almost 80 plus projects which have been executed since 78. So there are a lot of things we have done in carbon capture, removal and carbon storage. All these companies we have experience with. We have worked with all these companies. And this is one of the carbon footprint engineering tool, which we have an in-house tool, which we use to find the carbon footprint of any industries who contact us. So we can actually tell you what is the carbon footprint of that refinery or that chemical industry or that fertilizer industry. And we also give you recommendations how you can go about reducing those carbon footprints.
If I can request you to wrap up in a minute or so.
No, this is the last slide. Thank you so much.
Thank you.
Thank
Wonderful
you.
timing. Because we do want,
you
we
were
want
right on the time. Yeah.
That's terrific.
Okay, thank you.
I'd like to hand back to Ms. Mavis so that we can see if there are any questions on the chat. I don't see any questions here on the board.
There are a couple of questions which I have shared on the chat box, Dr. Anjan. Primarily, these questions are for Mr. Satendra Joshi.
You read them out, ma'am?
Should I read them in?
Yes, please. Thank you.
Okay. So the first question is, carbon footprint is regularly used word nowadays. However, to what extent do companies really take investing or reducing carbon footprint in reality?
Yeah. So should I go ahead?
Yes.
Yeah. So carbon footprint reduction is not just biofuel or something like that. It's definitely a lot more than that. For example, a water reduction or energy reduction also brings in the carbon footprint reduction. So if somebody wants to reduce the carbon footprint, then definitely energy reduction or water footprint reduction or any other consumption reductions also brings in the carbon footprint reduction. And that is definitely being considered. The only thing is that with respect to the GHG reduction or the carbon intensity number awareness, this needs to be brings in more. The awareness needs to be more in India. So we need to spread this perhaps to a greater extent. I hope I have answered the question.
Thank you. Yes, Mr. Joshi. Yeah, I think that's comprehensive. Back to you, Ms. Fernandez.
The next question again is for Satendra. The question is, as India is targeting high amount, around 20% of ethanol blending in gasoline, what is the impact on gasoline specification, particularly vapor pressure? How to address drop in calorific value of blended fuel?
I'm not sure whether I will be able to answer this fully, but the one thing is definitely being carried out in India is that we are working with a lot of auto companies. I mean, not Praj per se, but there is a lot of work going on with a lot of these auto companies. And in fact, there is work going on to introduce 100% ethanol engines as well. So there is a lot of work which is currently going on to have different ranges of ethanol in gasoline.
Mr. Gupta, would you like to?
Can I add something here?
Yes, sir.
Yeah. So we had this ethanol fuel here. I was using in my car here, but the efficiency wise, it was almost 20% less than the petrol. If my car runs 500 kilometers, it was running only 400 kilometers on ethanol.
Yes, we know that there's a fuel efficiency penalty. Mr. Shantanu, do you want to add? Indian Oil is one of the big players on the ethanol blending side.
Right, sir. Yes, it's a very, it's a very favorite subject for me, basically, we say that, because we are responsible for petrol as well as we are responsible for greening the petrol by blending. So up to 10% blending, what we are doing today. So we have extensive testing have been done. Fuel efficiency drop is maximum 1 to 2% for the engines, which is all E10 compatible. Now, when going for E20 compatibility, yes, for this current level of engines will definitely have a drop of 6 to 7% of mileage, and also there will be a problem in the softwares like the piping systems and all those things which will have to be replaced. But when we go for a flex fuel engines like E20 blend and then further, then the engines are tuned and engines are calibrated in the range of the characteristics so that the whole drop in calorific value is being captured for that. So that will be no issue. Once the automobile industries is switching over for E20 compliant engines from 2022 onwards, so which we are planning that 2025 onwards, there will be 100% E20 blending will be available. And then further the flex engines. So I don't think there will be any impact on that. That is from my side. Dr. Roy is expert in this area, so I will request Dr. Roy to add.
Thank you, Mr. Gupta. I think that the key point is that it will depend on the country, the jurisdiction, and the specifications. So to answer the question that was asked, I think that the vapor pressure impact is real, but as new engines come in, at least for the new vehicles, starting from next year, and definitely by 2025, we will not see an issue. With the existing vehicles, there might be adaptations required, to those vehicles might have to be able to use lower concentrations of ethanol. But as of today, even at E5, we see no real major issues. Let me go to the next question if you have one, Mr. Mendes.
The next question is for Ms. Shilpi Mittal. Could you tell us about India SABR biorefinery?
I think that's a confidential. She's already put it on the chat.
Yes.
Apart from just announcing the fact that they have an involvement in it, I think greater details will not be available at this time.
Okay, yeah.
Yeah,
Because the question is
thank
not
you.
relevant. Who is the client? Who is the technology licensor?
Yeah,
I don't think we can give that kind of information on this.
Yeah. Any other questions here? There are no other questions? Ms. Mavis?
I'm just checking if there is any more question. Give me one moment. Okay. So with this we end the third session for today and the third day of Refining and Petrochemicals World IE 2021. On behalf of Chemtech, I would like to take this opportunity to thank all the speakers, panelists, and especially the session chairs for joining us for the last 3 days in our online conference. And continuing to support us, I would like to thank Dr. Anjan Ray for the anchor presentation and for moderating our last session on biofuels. And also I would like to thank Mr. Satinder Joshi, Mr. Shantanu Gupta, Dr. Dilawar Singh, Ms. Shilpi Mittal for joining us this evening. And thank you so much for your support. And we look forward to meeting you all, hopefully in person for our next session, because now this is the second session that I'm anchoring online. So I hope things will change by December or January next year, so we can meet each other offline as well. And thank you so much, sir.
Thank you.
Thank you, everyone.
Thank you.
Thank you.
Have a good day.
Thank you so much. Thank you.
Bye-bye.
Thank you. Bye.